This video is going to go over how to take a spreadsheet and create a COGS calculation, which is your cost of goods sold. And this is going to be real useful whenever you're creating a product, baking stuff, or whether it's making a part for a jet engine. This is what you're going to need to create, something like this, to get a rough estimate of what you're doing in the beginning. And then after that, you should have a pretty detailed cost breakdown of the product you're making. So up here in the top, we'll just kind of walk through this, and then we'll start populating a few things to see how the prices change and your profit margin changes. And then you can use a advanced solver under the data tab to keep certain things constrained and change your price or adjust your annual goal to come up with what you need to make a profit. So we're going to start with the price of this product is set to $15,000. That's up here in cell A2. Materials, you can see, is in yellow because it's populated by another sheet, and you can put your bill of materials on the same sheet, but to keep it clean, it's best to put it on another sheet for your calculations. And that's over here on this sheet. You can see we have the quantity needed. Now this quantity needed, because if you're going to be making thousands of these units, you're going to be purchasing items in bulk. So the quantity needed is going to be the total quantity for the period that you're going for. So for this period, we have 12 months, and over here, so this, you're going to use 35 of these in 12 months is what all this is, because as you move over here, you can see that it's production cost each unit is your breakdown, and your production costs for the entire period, in this case 12 months, is over here. And so this cell down here, this G33, is what is driving your bill of materials per unit over here for your actual cost of goods sold for the unit. So the bill of materials, you just have quantity, part number if you want a part number in there, the name of the part, a description of the part, and then production cost each unit, production cost total unit, and then a sum down here at the bottom. And you notice that the hard code numbers are blue, and then the formula driven numbers are black. Labor for assembly is driven by the total over here. It's driven by I-15, which is over here. And this is a whole calculation we'll do in a few minutes here. We have, working our way down, we have the cost for patents. So if you're going to file a patent, you populate that right here, and then it amortizes the cost of that patent over the number of units that you're going to make. And tooling, regulatory fees, floor space, these are all formula driven, so are the names. So if you change your expenses that you put into electric, let's say you just want to call this utilities, you want it to update over here. We'll just change that back to electric. Marketing costs, E&O insurance, testing costs, one-time testing costs can be 10,000, 15,000. So you want to amortize that cost into the product so that you can recoup your expenses on that. Compliance software, if you're doing some type of device or any product really that requires additional software, design it. You could put in your cost for CAD software if you want in there. And then here we have a sum of what it costs for this entire product, and then the cost that you're going to spend for your goal, which so in this particular case, we're going to do 12-month goal period, and we're going to try and produce 1,200 for this. And this should actually be period goal for the period that we're going to work in. And so that's how much money you're going to spend over the course of the period to produce all these parts. And then you have gross profit per year. So it's your total revenue minus your cost per unit, and then total gross profit for the period. And we can clean this up a little bit just to make it look a little more streamlined. And then if you had other expenses that you would like to cover from the revenue of this, then you can add that in here and do some other calculations. But overall, our total revenue in this particular instance is going to be $18 million. And then total revenue per month, so it's just the number of units, or total revenue divided by the goal period. So 1.5 million per month. So if you did 18 months, changes all that. So we'll put that back. So I'll start over here. When you put together your task to assemble a product, and you can add as many tasks as you need, just keep inserting these in, shift cells down, and then you should be able to just add in the new task and add the number there, and it'll change it. So if you say it's going to take 7 hours to build each unit, that's loaded over here into estimated assembly time per unit. What you do up here is you put in the start date of the period. So in this case, we're doing this on September 22nd. So this is going to start October 1st. We're going to start manufacturing these. And since the period is 12 months, we're going to go through October 31st, 2026. Now we use the formula network days to calculate the total number of days available to work in that time period. And what this does is it takes out weekends and holidays. And you have your start date, your end date, and then your holidays. And you see that in this case, the holidays are all populated down here. Now the holidays that are populated in here, you can add them in there, but these are the ones that are sort of forced to recognize by the federal government under Section 5 of the USC code. These are the ones that you kind of have to shut down on. So it calculates your total days that you can work, and then it takes your annual labor hours. So if there's, and we just put 8 because you have 8 working hours per day, so it calculates 2,160. And then this one down here is added that if you for some reason are running a part-time schedule for this or what have you, you can factor this down. So if it's a part-time factor, then you do 50%. If you only got 50% of the time it can be worked on it, it's going to change some other stuff down here. Okay. So we're going to keep this at 100%. And then this is calculating the units required per work day. So if your total manufacturing goal for that period is 1,200, and there's 271 days to manufacture all these things, that means you got to do 4.43 units per day have to be coming off your assembly line. So you put in your labor hourly wage for your assembly technicians or whoever you have working for you. Now the effective daily work hours is 7.5 because you have setup time, cleanup time, things don't go right, you have to stop the assembly line for whatever, lunch, breaks, all that stuff, meetings. So you're going to have, let's say there's, on average, you have an effective daily work hours of 7.5 hours per day. So again, we have our estimated assembly time per unit, which comes from this table that we create over there. And what this does is it's going to calculate, it's going to round up. It's going to calculate the number of laborers that you need to reach your daily goal. So if you're going to produce 4.43 per day and it takes seven hours to do that, you need to have 5 people working full time to reach your goal of 1,200. And now if you take this stuff out, you can see that the number of laborers required to reach the daily goal drops. So this takes the number of labor hours that you're going to have to pay to get the units produced over the course of that time period, which in this case is 10,840 hours. And then if you're paying $25 an hour, you're going to spend $271,000 in labor. And then this calculates the labor cost per unit. So it's total labor cost divided by total number of units. So if we go over here and we put this up to 5,000, you can see it drops a little bit. Over here, you notice it says assembly floor space, because if you have a large facility and you're making multiple products or you're doing multiple services under this one roof, the entire building is not going to be taken up by the production of this product. So you start with the assembly floor space. And what we have here is square feet in the total building. So if you have a 5,000 square foot building, you're going to put that there. And then if your lease per month is $5,000 per month, you put the cost in there. And then this calculates your cost per square foot. And then this is the number of square feet required for this product. So if we change this to 1,200 square feet, then we're going to be spending $1,200 per square foot to manufacture this product. So if you make multiple products, you would do this for each product and calculate the cost per square foot or the total cost of that assembly area for each product to figure out what you need to charge. Make sure you're making a profit on each product. So you got your electric, and so this one's kind of hard. Unless you're using a watt meter on every single item that is drawing electricity, it's going to be difficult to calculate the actual amount of electricity that this production line is using. So you kind of figure it out. If you've got 2 products and your electric bill is $1,200 a month, and you just put $600 in here, Okay, notice there's an error in this. So what this needs to be is your average electric cost per month, and then this for average cost per working day, you're going to multiply the average cost per month times the number of months in the period, and then divided by the number of working days in that period. Your per unit cost can be average cost per working day divided by a number of units that you're going to create per day. So in this particular case, we're going to spend $6 in electricity to make 1 unit. Now, patents are something interesting because it's sort of a one-time cost. So if you spend $20,000 on a patent and you want to recoup the cost of that entire patent in the first year that you're manufacturing this, then this is what you would want to factor in as the cost. Now you could do another formula. Let's say you're going to do a 5-year plan. So this can be times 5. You can see it's $333 per unit if you want to stretch that out over the course of 5 years. Regulatory filings, registration fees with your state's Secretary of State or whatever you have, usually about $175, could be more per year depending on your type of company. And then if you have to do any kind of testing or certification, safety testing on this product, UL testing, things like that, you can build that in here. And then your marketing, that's going to be an ongoing thing. You're going to need to spend that every year, and you're going to need to spend more each year as the years go on to maintain market presence and things of that nature. So if your marketing budget is only $5,000 per year on this, then you would spend $4.17 per unit. Tooling, this is going to be if you have to do injection molding or make custom tooling to make the product, that's where you put here. Your compliance software, whatever you need to do, put that here. And then errors and emissions insurance, if you need that, you would put that here. So it takes the per unit cost of all these expenses and it loads it over here. And as we went over before, we can see that right now the way everything is structured, there's a really good profit margin on this, and you could drop this way down. So we drop down to 3,500. You get a total per unit cost of $23.30, cost for the goal, gross profit per unit, and total gross profit for the period is $1.4 million. So this is a very profitable product, whatever it is, and it's going well. Now, let's say that you get into a situation where if we just change this to 10 hours, and you can see that our gross profit per unit drops to $9.43, so our profit margin is getting lower. Oh, let's change our shipping cost too. Let's say each unit is going to cost us $15 to ship, and this is at $2,500. Now we're in the negative here. We're losing money on each product. And there's a lot of variables in here you could change. If we increase it, you can see that we're just going to go further in the hole. And let's say that we know that our production line, we can't do more than 1,200 units per year. Okay? All of our other expenses are kind of fixed. Except for task 1. There's some slack in how we do task 1. And there's slack in the price. What you can do is go to your gross profit per unit, and in the data tab, you click on the solver. Oh, let's reset all that. We're going to set objective of A17 to a value of, let's say we want to make 100,000. By changing the variable cells of price, do comma, and task 1. We're going to do subject to constraints. It's going to be price must be, let's see, less than or equal to, well, we want to say that the market demand is, the max we could go for market demand is $3,000. Also add in there that the time for task 1, we can't do it any faster than 5 hours. Let's see if it gives us a solution. Click solve, and looks like it gave us a solution where it just bumped this up to 3,000. It kept the task 1 at 10 hours, but if it needed to, it would have dropped that down a little bit more. Make sure that if you build this on your own, that the formatting matches this. make it nice and clean so that it's easy for you to put your numbers in there. If you don't have these actual numbers, then you should have quotes, you should have estimates. You can Google a lot of this stuff and get estimates on that stuff and figure that stuff out. If you have any questions, you can leave them in the comments. And so that's pretty much it for how to use this. I hope you enjoyed it. Thanks.